Hello, math humans. We're going to do 4.7a today. We're going to be talking about inverse trig functions. Our objectives are that we're going to restrict the domain, pardon my scribbles, to find the inverse trig functions, and then we're going to evaluate inverse trig functions. So remember, for a function to have an inverse, it must pass both the vertical line test and the horizontal line test. So we're going to consider the graph of y is equal to the sine of x. So, and my graph is kind of crappy, so it's a periodic function, so it would keep going. So notice that it passes the vertical line test, but it would fail the horizontal line test multiple times. But if I restrict the domain from a negative pi over 2 to pi over 2, then notice that it's going to pass both the vertical line test and the horizontal line test. So we are going to restrict the domain of sine from a negative pi over 2 to pi over 2. Okay, and it's going to be inclusive. Alrighty. Well, then we're going to do the same thing for cosine, and then we're going to do the same thing for tangent. Alrighty. So now let's talk about the notation. So if I want to do the inverse, we're going to talk about our notation. So if I want to do the inverse of sine, this is also going to be the same thing as the arc sine of x. Okay, so by restricting the domain, I made the inverse possible because it passed both the vertical and the horizontal line tests. My notation, y is equal to the inverse of sine, is also called the arc sine. And if we think about this on our unit circle, a negative pi over 2 is down here that you can't see, and a positive pi over 2 is up here. So we're going to restrict inverse sine or arc sine to the first and the fourth quadrants. Alrighty, so let's do our first example. So example number 1 is going to say evaluate. Alright, so the next part of our discussion is we start our example, arc sine of a negative 1/2. When you see arc sine or inverse sine and a value on the inside, this says what angle, because arc sine or inverse sine is asking you to find the angle, has a sine ratio of a negative 1/2. That's what this problem is actually asking you to do. So we're going to do this with our specials. Arc sine is limited to the first and the fourth quadrants. Sine is negative in the fourth. So this is a negative 1, this is 2, this would be radical 3. So my theta, right here, theta, is going to be a negative pi over 6, because opposite the 1 is a pi over 6. That's a pi over 6. Okay? All right, let's do another part of this example. So I want to do the inverse sine of radical 3 over 2. Okay? Again, arc sine is limited to the first and the fourth quadrants. Sine is positive in this quadrant, so this is radical 3 over 2 and 1. The angle is pi over 3, and so I would write theta is equal to pi over 3. And then the last piece of this example, if I want to do the inverse sine of 2, okay? So if we think about this, this says what angle has a sine ratio of 2, right? But think about the graph of sine. It oscillates between a 1 and a negative 1. So that means that this is not possible because it's outside the range. 2 would be up here. It's outside the range of where y is possible. Therefore, this particular problem is not possible. All right. So I want to talk about inverses from the form of a table. So if I had y is equal to the sine of x, and I put that information in a table, okay? And I did a negative pi over 2. The sine value is a negative 1. If I had 0 and 0, the sine of 0 right here, because the coordinates of that are 1, 0, the coordinates up here are 0, 1, and the coordinates down here are 0, negative 1. Sine is y. And so then if I had pi over 2, sine would be 1. Well, remember with inverses, so if I do the arc sine of x, when I do inverses, I flip-flop these coordinates. So then my x and y would be switched, so I would have a negative 1 and a negative pi over 2. The zeros would stay the same, and then this would be 1 and pi over 2. So if we think about the graph from a negative pi over 2 to pi over 2 for sine, it oscillates between 1 and a negative 1. So it would go from here, here, and here. So sine would look like this. But if I graphed arc sine, now I'm going from a negative 1, 0, 1, and then I would have pi over 2 and a negative pi over 2, and then my graph would go like this. So it's actually kind of interesting if we think about flip-flopping the points and then changing the graph. So now let's consider other functions. So if I have y is equal to the arc cosine of x, this is going to be limited to quadrants 1 and 2. Sorry, that's a 2. Whew, brain and hand aren't working at the same speed. If I have y is equal to the arc tangent of x, that's going to be the same thing as sine. It's going to be limited to 1 and 4. Okay, so arc sine, I'll just go ahead and write that down right here since we'll just put it all in one place. Arc sine is the same as tangent. It's 1 and 4. Arc cosine is 1 and 2. The other thing to notice on tangent and sine is since it's limited to 1 and 2, that means my angles have to go this way and this way. I can't go all the way around to get here because technically this is like no man's land, and I can't pass through no man's land to get to quadrant 4. So it's either this rotation or the negative rotation, and that's it. All right, so for example number 2, I want to evaluate, and of course we're going to do it by hand because it's way more fun. Okay. So I'm going to have 4, so we'll do number 1. I want the arc cosine of radical 3 over 2. Okay. Sorry, I'm just not going to change this. This is radical 2 over 2 because I want to remind you that it's really important. Makes the problem easier if you unrationalize it. So 1 over radical 2. Cosine is limited, arc cosine is limited to the first and the second quadrants. Cosine is positive in the first quadrant. So if I draw, this is 1, this is radical 2, this is 1. So theta would be pi over 4. Okay. The second part of this example, I'm going to have the arc cosine of a negative 1. Okay. Alrighty, and you can remember that these are interchangeable symbols. I could either write it like that. Arc cosine is limited to the first and the second quadrants. Cosine is, this point is negative 1, 0, when theta is equal to pi. Okay, so that's going to be my quadrantal angles. Anytime you have a 0 or a 1, positive or negative, these are going to be your quadrantal angles. Okay, all right, and then the last one of this, oops, sorry, I lied. I said there were 4. The third one is going to be the arc tangent of 0. And so if you think about this, tangent is 0 when y is 0, right? Because tangent is y over x, and for that to equal 0, y has to be 0. remember that arctangent is limited to the first and the fourth quadrants. Y is 0 right here. And so my theta is going to equal 0. Okay? And then the last one of these is an arctangent of a -1. Tangent is a -1, or tangent is a 1, when the y value and the x value are the same. That only happens in multiples of pi over 4. So if we think about using the same diagram, if arctangent is 1 and it's a -1, that means that it's in the fourth quadrant, and so that means that it would be this angle theta, and this is 1 and this is a -1, radical 2, sine divided by cosine, and this is going to be a -pi over 4, and that would be our theta. Okay? All right, so the arcs are actually pretty straightforward, but you do have to remember which quadrant each one lives in. And so just as a recap, arc sine is limited to the first and the fourth quadrants. Arc cosine is limited to the first and the second quadrants, and arc tangent is also limited to the first and the fourth quadrants. And that is it for today. Oh, I lied. Let's do one more example just because we haven't gone for very long. So we'll do one more example, example 3. So what happens when my brain and my mouth aren't working at the same speed? So I have the inverse sine of radical 2 over 2. I like to rewrite it. So this is the inverse sine of 1 over radical 2. Sine is positive 1 and 4. It's positive here. This is 1 radical 2. So I'm going to get theta is pi over 4. So the other thing that you have to remember, the arc or the inverse are asking you for the measure of the angle. They're giving you the ratio, and then they're asking you which sine, cosine, or tangent has this particular ratio. So you're always looking for the angle. 2, what if I ask for the arc tangent of radical 3? Well, that's the same thing as the arc tangent of radical 3 over 1. Tangent is limited to the first and the fourth quadrants. Tangent is positive in the first. This is radical 3, 1, and 2. So my theta is going to be pi over 3, because opposite the radical 3 is a 60. Then the last one, truly the last one, the arc cosine of a -1/2. Okay? Cosine is limited to the first and the second. Cosine is negative over here, so this is a -1, 2. This is a radical 3, so this is theta is going to be 2 pi over 3 because it's in the second quadrant. Alrighty, now that's it, and then I will see you soon.